Have you ever wondered how to develop a graphical user interface using Java for internet programming? Well, you're in the right place. Today, we're exploring the exciting world of GUI development in Java, focusing primarily on two key frameworks, JavaFX and Swing. JavaFX is the new kid on the block, offering a fresh modern approach to creating rich client applications. It's fast becoming the go-to framework for developers looking to create visually appealing interactive applications that work seamlessly with internet-based services and resources. This framework provides a set of modern GUI components, with everything from buttons and text fields to tables, trees, and menus. But that's not all. JavaFX also supports CSS for styling, making it a breeze to create visually stunning applications that really stand out. Plus, it comes with built-in support for graphics and animations, making it the ideal choice for developing complex and dynamic internet applications. But let's not forget about Swing. This tried and trusted framework has been the standard for many years, and it's still widely used today, particularly in legacy applications. Swing may not have all the bells and whistles of JavaFX, but it's a robust, reliable choice for developers working on existing projects that require maintenance or incremental updates. So, whether you're starting a new project and want to create a state-of-the-art application with JavaFX, or you're working on an existing project and need to stick with Swing, you'll find everything you need to know right here. And remember, developing GUIs in Java isn't just about choosing the right framework. It's also about understanding how to integrate these GUI components with internet functionalities. That means getting to grips with both GUI development principles and network programming. So, are you ready to dive in and explore the practical side of GUI development in Java? Now that we know what we're dealing with, how about we dive into the practical side of things? Let's kick things off by setting up JavaFX in our development environment. Ensuring JavaFX SDK is installed and properly configured is our first step. If you're running JDK8, rejoice! JavaFX comes included. However, for those using JDK11 or later, you may need to add it separately. Popular IDEs like IntelliJ IDEA, Eclipse, or NetBeans are all excellent choices for this task. Now let's dive into the structure of a basic JavaFX application. Picture a stage. In the world of theater, a stage is where all the action happens. Similarly, in JavaFX, a stage represents the top-level container, essentially our application window. But what's a stage without a scene? Well, it's pretty bare. In JavaFX, a scene is a container for all our graphical content, housing everything from buttons, text fields, to tables and menus. It's like the set design on our stage, providing the backdrop against which our actors, or in this case our UI elements, perform. Creating a stage in a scene is straightforward. We instantiate a new stage object, followed by a new scene object, passing in whatever UI element we want as the root. Then, we set the scene on the stage and call the show method on the stage. Just like that, we have ourselves a live performance. But we won't stop there. We want our application to do more than just exist. We want it to interact, to engage with the World Wide Web. To do this, we can incorporate various Java libraries that allow our application to send and receive data over the internet. HTTP client from Java 11, for instance, is ideal for sending HTTP requests to fetch data from web services. One crucial aspect to remember when dealing with network requests or any long-running tasks is handling threads correctly. JavaFX has specific threading rules that allow us to update the UI thread safely. The platform.runLater method is our backstage crew, ensuring that all updates to UI components from other threads are handled smoothly. With the basics out of the way, we can now enhance our application with internet capabilities. To make our JavaFX application interact with the internet, we can incorporate various Java libraries. This opens up a world of possibilities for our application, allowing it to fetch data, interact with web services, and more. One of these libraries is HTTP Client from Java 11, which we can use for making HTTP requests. This is a powerful tool that can handle both synchronous and asynchronous requests, making it a versatile choice for many applications. So, how do we use it? Firstly, we create an instance of HTTP Client. This instance can be reused multiple times throughout our application, reducing overhead. Then we build an HTTP request specifying the URL, HTTP method, and any necessary headers or body content. Following this, we send the request using our HTTP client instance and handle the HTTP response. Now here's the fun part. We can use the data we fetched from the web service to update our JavaFX user interface. This could involve populating a table, updating text fields, or even changing the layout based on the data received. But wait! Before we dive into updating our UI, we need to talk about threading. JavaFX, like many GUI frameworks, has a rule that only the UI thread can update UI components. But our HTTP request is likely running on a different thread, so how do we safely update the UI? This is where platform.runLater comes in. It allows us to schedule updates to the UI thread from other threads, ensuring that we don't run into issues with thread safety. So when our HTTP request finishes and we have some data to display, we can use platform.runLater to update our UI components. However, it's important to handle this properly. If we're making multiple network requests or performing long-running tasks, we need to ensure that we're not blocking the UI thread. This keeps our application responsive, providing a better user experience. Remember, when making network requests or performing long-running tasks, handle threads properly to keep your UI responsive. This not only makes your application more robust, but also ensures a smooth and enjoyable user experience. While JavaFX is the new kid on the block, Swing is the old guard, still widely used especially in legacy applications. In fact, Swing has been the standard for Java GUI development for many years, before JavaFX came along and stole the spotlight. But just because Swing is older, doesn't mean it's obsolete. Far from it. Swing continues to play a crucial role in many applications, particularly those that have been around for a while and have a substantial codebase built around Swing. Now, you might be wondering, how does Swing handle internet capabilities? Well, just like JavaFX, Swing can integrate with various Java libraries to interact with the internet. You can use HTTP client, for example, to make HTTP requests and fetch data from web services. But remember, when working with Swing, you need to be mindful of the Event Dispatch Thread, or EDT. This is the thread that handles all the GUI-related tasks. When we fetch data from the internet, we're typically dealing with long-running tasks. Doing these tasks on the EDT can freeze the GUI, which is not a good user experience. That's where background threads come in. You can perform the data fetching in a background thread, and once the data is ready, you can update the UI on the EDT using Swing Utilities InvokeLater method. This ensures that the GUI remains responsive while the data is being fetched in the background. Another thing to keep in mind is that, unlike JavaFX, Swing doesn't support CSS for styling. So, if you're used to the convenience of CSS, you might find Swing's styling options a bit limited. But don't worry, Swing still offers a wide range of components and layout managers to help you build complex and interactive user interfaces. Though Swing might seem a bit dated, it remains a viable option for existing projects that need maintenance or incremental updates. So, while JavaFX might be the shiny new toy, don't discount Swing. It's a robust, reliable framework that has stood the test of time and continues to hold its own in the world of Java GUI development. Whether you choose JavaFX or Swing, integrating GUI components with internet functionalities in Java requires a good grasp of both GUI development principles and network programming. To illustrate this, let's take a brief look at a simple Swing application. Imagine a JFrame that houses a single J button. When the button is clicked, an event is triggered. In the context of internet programming, this action could be used to fetch data from a server, update a database, or any number of tasks. Here's a snippet of what that could look like. This example is simplified, but it illustrates the core elements of a Swing application. You have a JFrame as your top-level container, a JButton as a user interface component, and an action listener to handle events. However, as we've discussed throughout this video, JavaFX is the newer, preferred framework for creating modern rich client applications. It offers a more robust set of GUI components, supports CSS for styling, and includes built-in support for graphics and animations. For these reasons, we highly recommend using JavaFX for new projects. That's not to say Swing doesn't have its place. It's still widely used, especially in legacy applications. If you're maintaining or extending a Swing-based application, you can still integrate internet capabilities using similar principles. So there you have it. Whether you choose JavaFX or Swing, the key takeaway is that both frameworks can be used to develop interactive and visually appealing applications that can interact with internet-based services and resources. With these basics, you're now well equipped to start creating your own Java applications with rich interactive GUIs that can interact with internet-based services and resources.